Static jumps are cool if you want to emulate some retro game experience or just evil, but I am a simple man with simple desires. If I jump near a small step, I want to reach the top of the step at least, and this behavior from a 3D game in 21st century is straight up trolling. What to do with it, however, is a rabbit hole. The most basic approach that can be thrown together is just to give alt run updates to the midair state. I didn't even implement it for demonstration, because alt run updates are spiky and we moved to more smooth approach. That's what happens if we are trying to accept rotation from WASD inputs during midair. I mean, it does a little bit more than I wanted from it. You can tweak the variables, but it won't cure fundamental flaws in the algorithm. Also, this behavior is cringe. What bugs me about rotation is the nature of controlled fall. In the most basic model, falling body accelerates downwards with a constant acceleration of g, and if that happened we got to control the fall, our control mechanism has an acceleration nature as well, so instead of rotating the vector, I would add a small fall control delta vector to it every frame. Here's the basic implementation for it. However, it still has some quirks. First is our forward input during the forward jump accelerates the player in a very noticeable way, and also this shit isn't cured. To combat the forward acceleration properly, do vector math to log the y coordinate and only add x and z portions, or just slap here a length limitation. Physics doesn't approve this solution, but no one will notice unless you have 100 feet falls in your game. Now, what produces this behavior? Well, the velocity is alright, it's just our face that is wrong. All this time we were slightly gaslighting ourselves by looking in the direction the velocity gives us, but when faced an obstacle, velocity guides us to the side thanks to move and slide, but we want our face to preserve the direction we want to fly in a world without this obstacle. Look in direction has nothing to do with current velocity, so what we will do is we store it in onEnter state and then modify it as independent parameter. My nemesis, the microstep, finally defeated. This is what suits my vision of the jump control. Not complete arcadeness, but the chance to modify the outcome of not so perfect jumping up. Now, I don't have much to tell about future paths, but there is still a problem I want to tackle that got additional context with our jump's evolution. Remember the slowpoke turns on the jump's borders? We can jump in the opposite directions still. I want to narrate my thought process about this problem a bit more. Here is the code that makes the jump ups responsible. What's good about it is that it does its job and we can now jump in the opposite directions like a bunny. But what's bad about this implementation is much more interesting. First, it's kinda funny how it works. Look, all my midair can do is this little delta input, maybe a meter of impact on a long jump, but my crazy jumping up animation is able to produce 180. This leads to the sudden leap in control the player has. During the start of the animation you are king, then after a short time you can do shit. This certainly can be mitigated with this variables customization, but firstly, based on what exactly, and secondly, my jumping up animation is a sort of glue state. It has the first half earthbound to mix with run, and then it has IRL part to mix with midair. It seems that I want to allow rotation only during the earthbound part. Also, the whole pattern behavior we are trying to fix is the unwanted results when spamming sharp jumps. And between two jumps are always two glue states, not only the jumping up animation from the second jump, but also a landing animation from the first one. Then the variables are starting to make much more sense. I want exactly the amount of angular velocity to be able to make 180 turn during the sum of earthbound parts of landing and jumping up. Then I want to stop my impulse to replicate this piece of code in the landings as well. Let's look again. What we will have after is a run, sprint, midair, 2 landings and 2 jumping ups. 7 states having the similar code. The code of the implementation is a bit different for every course, but it's there and it's still awfully similar in structure. We want our states to process WASD in updates. Now let's peek into the future. The next video will be about tracking, the ability to start the animation in one direction but to correct it with WASD during its life cycle. It's not that simple. Look at our inspiration source. We roll, then roll attack winds up statically, then we gain the ability to track the hit for a short time and then lose it again. We are dealing with a window here, and I have an answer for windows of any kind already. Backend animation can just have an hour track, but I have more. Let's use a completely unrelated to the channel gesture while pressing WASD during it. The player not only rotates, but walks slowly. So not only the gesture has an ability to track as a hit, it has a completely different implementation for tracking. Let's pause again and look at the whole project. Most of our behaviors actually do want to process WASD in inputs. Majority decides. If so, I would better implement a generalized default update cycle for all the moves that calls tracking method that will also have a default implementation. Then, if our gestures and midairs want to stand off, they could just redefine the tracking implementation. Now all is coming together. Us wanting to limit the rotation to the end of the lane and start of the jumping up is just a tracking window existence sign from above. But that's a story for another episode. Now, I will allow myself a small commentary on game creation as a whole. What makes me believe that game development and coding in general is an art form is that it allows exploration of unexpected results created by an artist by combinational using of a number of tools that have expected and explored previously outcomes. That's a long and formal way to say you don't know shit about what you are creating and it still can inspire you. Look at this behavior again. Ultra controllability for a character for several frames during exact phase of running state transition to aerial state. Could I predicted this outcome? No, I just slammed together the things that just worked previously. Is this result good? Well, I can say this result is undesired, but undesired is a function of goal setting. For a relatively slow fencing game with long lock-in animation, this ultra controllability is a glaring hole in the design. It almost punches you in the face by how unfit it's for a Souls game. But the mechanic itself is at least curious to explore. Look, with a little training I am able to curve the whole turn while flying. Also, our aerial controllability depends on the speed of entering midair state, so again, with a little training I can purposely slam myself into this angle and do this sharp turn. My goal setting makes me look at these behaviors as at cringe and vision breaking, but what if I were creating a movement shooter like Apex or its Titanfall parents? I would puke rainbows right now. I managed to give some rotations I can't fully predict, and my game magically shit out to movement techniques for speedrunners or ranked sweats to please themselves at night. That can be a perfect illustration for a benign feature not a bug approach. Also, a couple words about project organization. I got 2 pull requests for controller base branch cleaning up my Godot ignorance a bit, so I guess that's a community project now. However, these videos are pre-recorded and for Division reasons I made the museum project a separate repo and now it doesn't have these commits. As time will progress, I'll slowly re-implement them myself. Just be aware that the last branch of the controller tutorial now has slight alterations from Mechanics Museum series. For now, they are almost cosmetics though, algorithms haven't been changed.